In this lesson, we're going to introduce TCP IP, and the chances are you're using TCP IP right now. Whether you're watching this streamed over the internet, maybe you're watching this on DVD and in the background your computer is connected to some other service. It's checking email, it's updating its time. TCP IP is used for everything in computers today, and it really is what completes our computing picture. We can have the best file services, print services, media streaming, line of business applications. But unless they can communicate with each other and clients can communicate to those services, they are useless. And TCP IP, and specifically IPv4 that we're going to talk about in this module, is really the de facto standard with regards to computers connecting today. As I think back to my earliest roles as a VAX VMS systems administrator, at that time we didn't actually have TCP IP. We had DECnet OSI. And the Open Systems Interconnect model, or OSI, that you can see on the screen here, really goes back and is some of the most fundamental networking concepts that are out there. And it really broke things down into 7 layers. A physical layer, i.e. the actual media in which the communications were going on over. Data link, how those communications were structured. Network, how they are actually communicating in terms of an agreed protocol. Then a transport layer, a connection or connectionless based communication. Session, how they maintain a relationship between 2 machines, any presentation information, and then application. And really with TCP IP, they simplified these layers, which you see on the right hand side. So think of a network interface, and really things like Ethernet and token ring are the common examples, with really Ethernet being the most common one we'll see today in most companies. Then we have the internet layer. So this is the protocol used for the addressing and the overall communication. For example, IPv4. But IPv4 also has some other partner protocols. For example, ICMP for error checking, communications when there's a problem, ping, which we'll actually talk about later, and address resolution protocol for actually translating an IP address into a physical MAC address of a network adapter. IGMP for multicast communications. And then the alternative to IPv4 is IPv6. And again, we're going to talk about this later on. It is one of the more modern standards with a goal of addressing the shortage of IPv4 addresses. Then on top of that, we have transport. And transport is really TCP or UDP. TCP provides a connection-orientated communication for an application. So because it's connection-orientated, it's reliable. It's going to make sure data between the client and the server is successful. It confirms all the packets are received, and this means the application doesn't have to worry about the packets and the data. It's assured that TCP is going to take care of making sure all the packets were received and re-getting packets if they're missed. UDP is a connectionless and really an unreliable protocol. It doesn't make any checks about were packets received, was there any data potentially lost. It's assumed the application will take care of this. But it has advantage over UDP in that it's faster, there is less overhead. And so for some functions, UDP is a better option. Media streaming, for example. If a packet is missed in a media stream, it's better to just carry on and ignore that frame, ignore that packet, than to try and pause and go back and get that packet. So the transmission control protocol is what we're going to see in a lot of connection-orientated, reliable communications. And that user datagram protocol, the UDP, is for the more connectionless, less reliable. And then we have the applications that use this transport. For example, HTTP for your web browsing, FTP for file transfers, SMTP for your mail delivery, DNS to look up names, Telnet, is not used as much today as in the past. Was a sort of command line based interface to other machines. And all of these different layers make up our communication based on the TCP IP protocol. And what we're going to look at throughout this module is actually what is TCP IP, how do we do the addressing, how does it work under the covers, and then how are some of the key things we can actually do to troubleshoot this.